FRQ 321 is a great question. Really make sure you understand this one. So we have the temperature of water in a tub, and it's getting hotter. Twice differentiable. WT is in Fahrenheit, so we have Fahrenheit in minutes. So this is an initial raw data question, no derivatives in this data. Remember at time t equals 0, it starts at 55, so you do have an initial value. The water is heated 30 minutes, beginning at t is 0. And so for the first 20 minutes, it's given in the table, which probably means there's something from 20 to 30 or something. So let's look at A. Use the data to estimate W prime of 12. Now, do you see the pattern? First question is, tell me what the rate of change is at time 12. Then you have raw data. And so 12 would be between here and here. So that's an average rate of change question, right? To get the derivative at a point when you have data. So we would say that W prime of 12, and they ask it specifically, so you're going to say that, is approximately equal to, and then the average rate of change, W of 15 minus W of 9 over 15 minus 9. And this is calculator active, so you can do it out in your head, or you can use a calculator. You get 1.017 degrees Fahrenheit per minute. Make sure you have a rate, okay? And because use correct units, it says over here, using correct units, interpret the meaning of the context of this problem. And so what does that mean? Well, doesn't it mean that at time t equals 12, okay, that's what the temperature, and we found a rate, so is increasing because it's positive by 1.017 degrees Fahrenheit per minute. All right, so that was part A. Point-wise, that was worth 2 points. You get 1 point for the 1.017 and 1 point for the reasoning with units. All right, let's go to B. B says, use the data in the table to evaluate 0 to 20 of the of W prime of t. Using correct units, interpret the meaning of 0 to 20 W prime of t in the context of this problem. Okay, well, we know how to do that. This is the fundamental theorem of calculus, so we would say that 0 to 20 of W prime of t is equal to W of 20 minus W of 0, just like in the other one, which is equal to 71 minus 71 minus 55, which equals 16 degrees Fahrenheit. Now look, that obviously, if you take the integral of a rate, you get just the temperature, right? So make sure you use the right units. That would be 16 degrees Fahrenheit, and it says interpret the meaning. So we would say that the temperature of the water changed 16 degrees Fahrenheit from t equals 0 minutes to t equals 20 minutes. All right, so that was part B. Pretty standard, I swear. Know how to do this. You're going to get some points off of this. So this is worth 2 points. You get 1 point for getting 16 degrees Fahrenheit and 1 point again for the reasoning of what 0 to 20 of W prime of t is. So let's go on to part C. Part C says for 0 to 20, the average temperature of the water is 120, So you can see they have this average value formula. It says use a left Riemann sum with 4 subintervals to approximate this average. Now I'm going to tell you right away, do not forget the 1 over 20, okay, when you do this. So write it down right now, because you're not just doing the Riemann sum, you're doing the average and the Riemann sum after that, multiply by that. So then it asks if it's an overestimate or an underestimate, so we'll deal with that. So first let's do a left Riemann sum. Now remember, first we use left, so we would use the left sides and not the last one. So I'm going to circle those, so I use them, and then X out that. And then I'm going to look at my time intervals. That one's 4, 5. That one would be 6. And then 15 to 20 is 5. So I know my time intervals, and now I know my, so my widths are the time intervals and the heights are the WT. So I can sit there and go, okay, so then it would be 4 times 55 plus 5 times 57.1 plus 6 times 61.8 plus 5, times 67.9. So use your calculator to calculate that, and you get 60.79 degrees Fahrenheit. Make sure, I would put up here that 1 over 20 of 0 to 20 of WT dt is equal to that. So that is the average temperature, right? Look at it. Does that look like it could be an average temperature? It does. Make sure, okay? Make sure it makes sense. Now, it asked if this average temperature, what we got, an estimate, so we probably could make squiggly lines, is an under or over estimate. And so you have a left Riemann sum, and you have it says strictly increasing. So this doesn't count, but what you write will, but I'm just going to show you this. You can do this even. Here is an increasing curve, and I'm going to draw in my left. I'm just going to draw my lines down, right? These are the areas. And if I do left Riemann, it's from the left, you can see that I am underestimating. Now, the reasons that you put down is you say, because the function is strictly increasing, right? And you're using, and use, let's just say and use instead of you and all that, don't waste time, and use left Riemann sum. The approximation is underestimate. Okay, under. All right, so what was that? That was C. Okay, so points for that. Did I do points for B? Yeah, okay. Let me go back and do points for C. So C was worth 3 points. You get 1 point for this Riemann sum, left Riemann sum. You get 1 point for the answer, and you get 1 point for the underestimate with the reason. Great, great question. All this stuff is so open to be on that exam. So trying to get, enough points to show what you know. This really shows you know what you know. Let's go to D. Let's shrink that down a little so I have some room. Okay, so D says, for 20 to 25 minutes, the function W models this function right here, the derivative of that function. Oh, based on the model, what's the temperature of the water at T equals 25? So aren't we talking about the net change from 20 to 25? And so you know how to do net change, right? You have to use your initial value. So let's just write it down. So you would say that I want the W at 25. That's what it's asking. What is the temperature at T equals 25? So isn't that W of 25? That's equal to W of 20. We're doing a net change, so we have to start where we were at 20, whatever that was. So like, if it was 60 degrees, then you would start there and then take away or add whatever was going after it, right? Well, we know it's 71 degrees, so I'm saying. So it's 71 plus whatever was done between 20 and 25. So you would use 20 to 25 of W prime of T dt. Now, that's equal to 71 plus, and then you would put this into your calculator with that function, that cosine function. But you never have to write that out because this is a calculator question. Of course, they're not going to give you a calculator question, so you would be writing out your work. So you're going to have to show you can do definite integrals right correctly. So 22.043. So it's equal to 73.043 degrees Fahrenheit after 25. So it doesn't say interpret that or anything. So let's see what points we get. This is worth 2 points. You get 1 point for this integral statement, and you get 1 point for the answer. So that should be your 9 points. That's 2, 3, 4, 5, 6, 7, 8, 9. All right, so there was FRQ 321.